Alright, so this video is going to be reviewing exponent rules. So take a second, write down this first problem, pause the video, try it on your own, and then come back. Alright, welcome back. So for this first one, most people say, okay, well, we're multiplying, so I'm going to multiply these two together, and we're going to get x to the 9th. Okay, but we have to be very careful because this is not right. Okay, so let's start by rewriting these x to the thirds. So I'm going to rewrite it as x times x times x. Okay, and then we're multiplying here. So we're multiplying these together. X times x times x. Okay, well, this multiplication sign is the same thing that we're doing here, and the same thing that we're doing here. So I'm going to write it like this. So now I just pushed all of them together. Well, how many x's do we have? We have 1, 2, 3, 4, 5, 6. So what's our answer? Our answer is x to the 6th. So going back to this one right here, x to the third times x to the third. Well, what do we do to solve this? Well, when we're multiplying exponents with the same base, we take our exponents, we add them together to get x to the 6th. And this is the reason why we add them. Okay, so take a look at x to the 5th, x to the 10th. Okay, take a second, pause the video, try this one on your own, and then come back. All right, welcome back. So this one, same bases. So we have 5 plus 10. So our answer is x to the 15th. Right? And it's because of this reason. If we were to write all of these out, we'd end up with 15 x's, and then we'd have x to the 15th. All right. Well, let's look at this one. Well, what's different about this one? Well, our bases are different, so that means we cannot multiply these together. So this would just be the same thing. So we can't do anything with this one. So when the bases are not the same, we can't multiply them together or add these together. Okay, so now let's talk about third to the second. Okay, so now we have an exponent in a parentheses with another exponent. Well, how do we do something like this? Well, let's write it in a way that can kind of simplify it here. So x to the third squared, well, this just means I have two of them. So I'm going to rewrite it as x to the third times x to the third. Okay, well, we've seen this problem before. It's the same thing that we started with. So for this one, remember, same bases, we add the exponents, we get x to the 6th. Like that. Okay, so then pause the video and try this one on your own, and then come back. All right, welcome back. So this one, x to the 4th, now we have to the third. So let's rewrite it. So we have x to the 4th times x to the 4th times x to the 4th. Right, because all this means is that we have 3 of what is ever in the parentheses. So we rewrite it as that we have 3. We add all of these together, so we get x to the 12th. And there's our answer. Okay, last thing we are going to talk about is negative exponents. So let's say we had something like this, the negative 1. Well, what does this negative mean, right? We know how to do something like this. 5 to the first is just 5. But what does this negative do? Well, this negative actually flips whatever this number is, okay? So we take the reciprocal of it. So here, we can rewrite this as 1/5 first. And we really don't need to write this first here, because anything to the first is just itself. So this would be 1/5. Okay? Now what about if we had 5 squared? Okay, well we know it flips this number. Okay, so then we have 1/5 squared. So when we flip it, we keep the same number, we just now make it positive and not negative. Okay, and then 5 squared is equal to 25. So we have 1/25. Okay, so go ahead and try this one. So pause the video, try it on your own, and then come back. Okay, so again, we have this one. We have a negative exponent. That means we flip it. So we have 1/3 to the third. Well, what's 3 to the third? 3 to the third is just 3 times 3 times 3, which is 27. So 1/27. Okay. And then we can think about going the other way. So if I had 1/2 to the second, well, this is the same as 2 to the negative second. So now we can go the other way. So let's say I had 4 to the negative 1. Sorry, 4 to the first, sorry. 4 to the first. Well, I can rewrite this with a negative exponent. I get 4 to the negative first. And these are equivalent. These are the same. So we can think of ways to rewrite fractions with exponents. So this one. Well, how can we rewrite this? Well, we can rewrite this as 5 to the negative second, right? And the reason I get that is this is the same as 5 squared. Well, I can use a negative exponent to get this. All right, so we are going to be applying these ideas to our next unit with logs and exponentials.